Okay, here's page 3 and 4 of transformations. Um, what are the three kinds of transformations we will study in this chapter? Let me bring the book out for you. So if we go to page 141 of the book, we can see that we're going to perform transformations, including translations, stretches, and reflections. And then we're going to think back to the investigation we just did on transformations. We used a uh, complex polynomial that looked like this. Okay, it had a few sliders in it: P, Q, A, and B. Okay, Q appears in two different places. A appears in two different places. What kind of transformation does each slider perform, and in what direction, X or Y? So let's take out our Desmos investigation and check that. So we can see our function curve here, and then we have our four sliders, A, B, P, and Q. So if we take the A slider and move it left to right, the function moves in the X direction left and right, right? If we take the B slider and move it left and right, the function goes up and down. What about the P slider? The P slider stretches the function up and down. And the Q slider stretches the function left and right. Okay, so let's bring back the problem set, and then we'll record that. Okay, so the A slider does a translation. Oops, does a translation, which is it's a transformation which goes either in a lateral direction, horizontally, or vertically. So it's a translation in the X direction. Okay, and then the B slider also is a translation. It goes in the Y direction. The P slider is a stretch in the Y direction. And the Q slider is a stretch in the X direction. Remember Q was this one. So it's a stretch in the X direction. Okay, and so those are the four main translation stretches. There's also reflections, which we didn't do the investigation, but reflections are something we worked with inverse functions, right? When you reflect a function about an axis, it turns upside down, or it becomes a mirror image of itself, left and right. Okay. All right. Now here is an example that tells you how to do the next few problems in exercise 5B. Um, Basically, this is something we've done before too. Um, we make a composite function out of two functions. So you take the function 2x and you put it inside the function x squared, for example, and then you end up with 4x squared. Okay, so let's go down and we're going to do composite functions below, except the notation is a little bit different. We don't have two different functions. They just write the other function inside the function they give us. Now this is such a simple case, it may be hard to understand what you're doing because f of x is just x, so you really don't do anything. F of x equals x is actually a diagonal line. It's actually the line that we reflect over when we make an inverse, if you remember. So if we substitute 2x in for y equals x, all we get is y equals 2x. If we substitute x in for x, and then we add 2, then we just get x plus 2. And then if we put x in for f of x, and then we multiply by half, then we just end up with y equals half x. And if we take the function x and we multiply by 2 and we add 3, we just get 2x plus 3. Okay, so that was number 1. Number 3. So we have the function x cubed. So this is a little bit more complicated. Maybe it'll be easier to understand what we're doing here. We're going to take whatever's inside the parentheses and we're going to put it into the function. So for example, if we put 4 of x inside the function x cubed, we'll have 4x cubed. And then we can simplify that. We could say 4 cubed x cubed. The cube needs to be distributed to each of the elements here. 4 cubed is the same thing as 64 x cubed. Here you have 1/2 2x, so you're going to put 2x inside the cubed, and then you're going to multiply it by 1/2, because half is on the outside, right? And that would be the same as 2 cubed is 8x cubed times 1/2, so that would be 4x cubed. F of x plus 1, so you put x plus 1 inside the function. And then that's the same thing as, if you want to like expand that, you can, but you don't really need to expand that. You just make a big mess. Here you put x plus 1 inside the function, so x plus 1 inside the cubed, multiply it by 2, and then you subtract 3. Okay, all right. 4. If f of x equals 2 to the x, find in the simplest form. And here again, all you're doing is you're taking what's inside the parentheses and you're going to substitute it in for the x of the function. So it would be 2 to the 2x. This would be 2 to the negative x plus 1. This would be 2 to the x minus 2 plus 3. This would be 2 times 2 to the x plus 3. You could also rewrite this one as 2 to the x plus 1 plus 3. I guess all these, you could like do things like, oh, I'm going to change that to 4 to the x, for example. You could do 2 squared. Here you could say, oh, and that's 1 over 2 to the x plus 1. Here you could say 2 to the x minus 2 is the same thing as 2 to the x over 4 plus 3. Okay, I don't know if that makes them simpler or not. If f of x equals 1 of x, find in simplest form. Okay, so again, all you're doing is taking what's inside the parentheses and substituting it for x. So it would be 1 over negative x. This would be 1 over 1/2 x. This would be 1 over x quantity times 2 plus 3. So you could rewrite that as 2 over x plus 3. This would be, you put the x minus 1 into the function, and then you multiply it times 3, and then you add 2. So you could rewrite this as 3 over x minus 1 plus 2. And I think that's it.